Look around today and you realize facial recognition software isn't some futuristic idea. It's already being used, from boarding a plane to unlocking your phone. AI will fuel growth in the use of this technology. Before the rise of modern AI, facial recognition was built on more traditional computer vision methods, measuring distances between eyes, nose, mouth, analyzing fixed features. These early systems struggled with changes in lighting, pose, occlusion, anything that deviated from ideal conditions. Researchers realized they needed better databases, more consistent images, more standardized tests. Programs like Ferret in the 1990s helped establish that foundation, giving the field a way to compare algorithms and evaluate progress. Over time, systems got better. Machine learning came in. Deep neural networks learned to extract more robust, flexible representations of faces. Even so, as systems improved, evidence mounted that errors didn't happen equally across all people. False positives, where the system incorrectly matches two different people, turned out to be a serious issue. False negatives, failing to match two images of the same person, also matter, but false positives often carry heavier consequences, especially in law enforcement or surveillance settings. Multiple studies revealed that false positives were notably more frequent for people who are women, people with darker skin tones, certain age groups, and specific racial or ethnic backgrounds. One landmark report from the National Institute of Standards and Technology, NIST, showed that for many face recognition algorithms, false positives rates for Asian and African American faces were far higher compared to Caucasians. In some cases, algorithms were 10 to 100 times more likely to wrongly match images from Asian or Black people versus white people. The report also found that African American females often had among the highest false positive rates in one-to-many matching, meaning when a face is searched against a large database. These disparities revealed not only that bias exists, but that it's deeply tied to training data, algorithm design, and demographic representation. While false positives have historically been a major weakness, there's promise in how AI is helping to improve accuracy. Modern face recognition uses embedding methods like FaceNet, deep convolutional neural networks, and loss functions designed to bring images of the same person closer together in feature space, even when lighting, angle, expression, or occlusion change. Training datasets have become more diverse and larger, incorporating images from many different demographic groups under various conditions. Another tactic has been synthetic data augmentation, simulating masks, occlusions, different lighting or low-resolution images so that models can learn to cope with non-ideal inputs. Improvements also come through post-processing type fixes. Fair score normalization is one. Instead of directly retraining models, these methods adjust the way scores are interpreted after a comparison so that one decision threshold doesn't unfairly advantage or disadvantage certain groups. Studies show that such normalization methods can reduce demographic bias significantly without degrading overall accuracy. Another approach, shown in recent work called Falcon, fair adaptation through local optimal normalization, treats individuals with similar traits similarly and allows for a trade-off between fairness and accuracy, boosting performance even as bias is reduced. It's not just laboratory work. Real-world evaluations like NIST's Face Recognition Vendor Test, FRVT, benchmark algorithms under many conditions and demographics. In those tests, the best algorithms perform much better, showing both low false matches and better equity across race, gender, and age. But despite progress, error rates are still not uniform. Inaccuracies still spike when image quality is low, lighting is poor, or faces are partially occluded. In law enforcement contexts, even a single false positive can lead to wrongful stops or arrests, so the stakes are high. Since facial recognition is already in use everywhere, what matters now is how to make it more accurate and fair. First, ensure datasets are diverse in representation and image conditions, lighting, angle, resolution, occlusion. Then use smart model architectures and loss functions that encourage robustness across those variations. Employ pre-processing steps, align and normalize faces, correct lighting, maybe even upgrade hardware or image capture to reduce noise. Also, Consider post-processing and calibration methods like score normalization or threshold adjustment so that decision thresholds do not disproportionately harm certain groups. Always include human oversight, especially in high-stakes applications like law enforcement. Also establish independent benchmarks and evaluations to compare performance not just in ideal settings, but in difficult and varied real-world conditions. And finally, be transparent about error rates, biases, and limitations so that users, policymakers, and the public understand what the technology can do well and where it still falls short. When you put it all together, the story is clear. Facial recognition has come a long way, driven by advances in AI, larger and more varied datasets, and smarter methods. But it is not yet perfect. The remaining errors and biases matter. The key isn't whether facial recognition is being used. It already does. But how well it works, how fairly it treats different people, and how responsibly it's used. Please like, subscribe, and share. This video was prompted by a user comment. Thanks for listening. I'd be interested to hear, have you ever experienced or heard about a misidentification? Do you think advancements in AI will make this technology safer, fairer, and more accurate?